Good evening, everyone. Today, we're going to do the part 2 video of three-dimensional geometry. Today is a part 2 section or the second section of three-dimensional geometry. And what are we going to learn here? Today, we're going to do equations of line in a space. In my previous video, I told you how to solve all the sums from the first exercise, which is based on DC and DR. And now I'm going to tell you how to find the equation of a line in a space. Okay, so let us take the diagrams and theory from the NCERT textbook. Right. Equation of line in a space. A line is uniquely defined if it passes through a given point and has a direction, or if it passes through any two given points. But if you ask me, the second one is irrelevant because we can do all the sums just by understanding the first thing. Okay, let me go back to the equations of straight lines that you've learned in a two-dimensional space. In two-dimensional space, how do you find equation of straight line? Y minus y1 equals m times x minus x1, isn't it? Wherein m indicates the slope of the line segment and x1 and y1 indicates the passing through point. So in order to find equation of a straight line, we only need these two information, a passing through point and a slope. Correct? Now, here also we need only two information. One is a passing through point, a point through which the line passes through, and the direction of the line, the direction vector. So whenever there is a question which is focusing on equation of line in a space, just look for these two information. One is a passing through point, two is a direction vector. The rest of the things will automatically rely on this information only. So there is no use or there is no need to learn multiple formulas on the same concept. Okay, so let us see the concept here. So here a diagram you can see in your book. All right. So the point that I was discussing is the point A here. Point A is the given point. And B is the vector of a line that's parallel to the required line. So A be the position vector of a given point, small a vector be the position vector of a given point, and L be the line, which means the required line for which they've asked us to find the equation, which is passing through point A and it is parallel to a given vector B. Okay. So B vector is a direction vector of another line segment that is parallel to L. Or you can just say that B is the direction, B is just a parallel vector. Now we are asked to find the equation of this line L. Okay, as you can see the line L is passing through A and P. So what is P? P is any arbitrary point. So whenever there is an equation is the path traced by a set of points. Correct? So, and obviously all the equations are in terms of x and y, isn't it? Even here see x and y is there. So what is x and y? It is just an arbitrary point. So here also P is considered as x comma y comma z, which is an arbitrary point. So P is any point which is x comma y comma z, an arbitrary point. So when you make that into a position vector, you get an OP vector and that is considered as an R vector. So A is a given point, P is a parallel vector, B is a parallel vector and P is the arbitrary point which we make it into an OP vector which is considered as an R vector. Now, as per the question, AP is a line segment which is parallel to this line. Correct? Right. So that means AP vector will be lambda times of B vector. Parallel means one is proportional to the other. Correct? So AP vector is lambda times of B vector. Now how do we find AP vector? Using position vector, we find AP by OP vector minus OA vector. So AP vector equals OP vector, which is R vector, an OA vector which is small a vector. So AP is what? R minus A. And since AP vector is lambda times of B vector, R minus A vector is equals to lambda times of B vector. So that means R vector will be A vector plus lambda times of B vector. So this is the equation of the line L, where A is the passing through point, where A is the position vector of the passing through point, and B is the direction vector. Okay? And what is this? Why do we have R in the equation? And do we need to find lambda? No. Ideally, lambda would be there in all the equation. And R is the way of writing the equation in vector form. An equation can be represented in two forms. One is a vector form, wherein R vector will be there. So R vector equals A vector plus lambda times of B vector. And then is a Cartesian equation, which means an equation in terms of x, y, and z. There is also a formula for that, but rather than learning or memorizing the formula, just learn the technique of getting it to Cartesian form from the vector form. Okay, so I'm just going to show you that now. Hope you remember what is R vector. R vector was OP vector and P was any arbitrary point which we took it as x, y, z, right? So R vector is what? Xi vector, Yj vector, Zk cap. Correct? Now, A vector. Let's go to the diagram and figure out what is A vector. A vector was based on A point. And let's assume A point as, let's take A point as x1, y1, z1. x1, y1, z1. And B vector as A1, A plus AI plus Bj plus Ck. So let A vector will be x1i, y1j, z1k. And B vector be AI, Bj and Ck with cap. Now apply that in the vector formula. What is vector formula? R vector equals to A vector plus lambda times of B vector. R vector is xi, yj, zk. A vector is x1i, y1j and z1k plus lambda times of B vector, which is A1i or just A1, not A1, AI, Bj plus Ck. Now, when you compare the components of I or when you compare the coefficient of I of both sides, you get x equals x1 plus lambda A, which means x minus x1 by A is lambda. Like that, if you compare the coefficient of j on both sides, you get y equals y1 plus 8 lambda times b. So y minus y1 by b equals to lambda. And same way for k also. Comparing the coefficients of k, you get z equals z1 plus c lambda. So z minus z1 by c equals to lambda. So everything is lambda, so that means they are all mutually equal. So the Cartesian equation is x minus x1 by A equals y minus y1 by B equals z minus z1 by C. Okay, where x1, y1, z1 are nothing but the A vector's components. A, B, and C are nothing but the components of B vector. So instead of memorizing this as a formula, you just learn the trick of converting it to the Cartesian form straight away. That will help you in a longer run. Now, when I started explaining, I said only first information is enough. And I said I'm not going to consider the second one. Isn't it? What I said is I'm not going to consider the second formula given in the book in my working, because I'm going to do all the sums using the first formula, which I just said r vector equals to a vector plus lambda times of b vector. Now, how is that possible? Listen. Here it is a line that passes through 2 points. So imagine a line segment that is passing through 2 points, say A and B. A line that passes through 2 points A and B. Let's consider a line segment that passing through point A and point B. Now, in order to find the equation of a line in a space, we need two information. One is the passing through point, the other one is the direction vector. Now, if I consider A as my point of reference, then an AB vector will be the direction vector. Or if I consider B as the passing through point, BA vector becomes the direction vector. So it is according to me whether what to be taken as the passing through point. I would take A as my passing through point. Now this time I'm going to take examples rather than x1, y1, z1 values. So let's take this is 1, 2, 3 and this is 0, 1, 4. Alright. So OA vector is what? The position vector of point A, which is I plus 2j plus 3k. And what is AB vector? Which is the direction vector, which is OB minus OA. Right? And that will give me 0 minus 1 minus I, 1 minus 2 minus j, and 4 minus 3, 1k. 0 minus 1 minus 1, 1 minus 2 minus 1, 4 minus 3 plus 1. So this is AB vector. So OA is the position vector of a passing through point A and AB is the direction vector. So the formula is R vector for the vector form. R vector equals to A vector plus lambda times of B vector. So R vector equals to A, which is I plus 2j plus 3k plus lambda times of minus I minus j plus k. Isn't it simple? We didn't learn any new formulas. So this way we found the equation of this line segment in vector form. Now I want the Cartesian form also for this. What is R vector? R vector is arbitrary points vector xi, yj and zk. If I put that in the place of R vector, I get xi, yj, zk cap equals I plus 2j plus 3k plus lambda times of minus I minus j plus k. Well, it's must to put the cap. If I fail to do it, you don't do that. So you get it like this. Now compare the coefficient of I and come to the answer straight away. What do I get? X minus 1 by minus 1. Isn't it? Y minus 2 by minus 1. And Z plus 3 by 1. X equals 1 plus minus lambda. So x minus 1 by minus 1 equals lambda. Again, y equals 2 plus minus lambda. And therefore, you get y minus 2 by minus 1 equals lambda. Then comparing k, z equals 3 plus lambda. So z z minus 3. Oh yeah, z minus 3 here, not plus 3, z minus 3. So z minus 3 by 1. So this is how we get the Cartesian equation straight away. Okay, so we saw equations of lines. Next is angle between two lines. The standard form of equation of a line is this, correct? R vector equals A1 vector plus lambda times B1 vector, where A1 is the passing through point, B1 is the direction vector. When I say passing through point, you should think that it's a position vector of the passing through point, okay? Like that for the next line also. Now, in order to find the angle between two lines, we do the same angle formula that we did in vector algebra. Dot product of the direction vector by the magnitude of the vector. So, the direction vector is B1 and B2 here. So, don't take A1, A2 because it's the position vector of the point. So, you take the direction vector and then you apply this formula to find the cos angle, the angle between the two vectors. Now, what happens if the lines are parallel? The lines are parallel, B1 will be lambda times of B2. And if the lines are perpendicular, dot product of B1 and B2 is 0. Okay, so this is how we find angle between two lines. This is the next type of questions in the second exercise. Okay, so let us see the book sums now. Here is the second exercise. I'm going to brief all these sums. Only some selective questions I'm going to do it and show you because these are concepts that you have already learned, so it's easy. Show that the three lines with the direction cosines are mutually perpendicular to each other. So this is the direction cosine of line 1. This is the direction cosine of the line 2. This is the direction cosine of the line 3. If the lines are perpendicular, what happens? The direction dot product of direction vector is 0. Isn't it? So consider this as B1. Consider this as B2. Consider this as B3 or ABC as you want. Now multiply dot product. If B1 dot B2 equals to 0, B2 dot B3 equals to 0, and B3 dot B1 equals to 0, then they are mutually perpendicular. So there will be 0 here. Okay, so that's how we do the first sum. Second question. Show that the lines through these 2 points is perpendicular to the line through the points. So that means a line is passing through 2 points. Well, are we supposed to find the equation? No. We only have to find the direction vector of this line. So, second question. Plot 2 points, give it a name to it, A and B. Find AB vector, which you know OB minus OA. The next line, give it a name CD and then find CD vector. Now see whether AB vector dot CD vector equal to 0. Then they are perpendicular. Third question. Show that the following points are parallel. The same diagram, very much the same, but here we need to get AB vector is equal to lambda times of CD vector. So if you prove, then they are parallel. Fourth question. Find the equation of a line that passes through a point and parallel to a given vector. Okay, so here they want us to find the equation of the line. Remember what I said. I said to find the equation of line, we need only 2 information. 1 a point and 2 a direction vector. We know the point, right? We know the point as 1, 2, 3. So A vector will be I plus 2j plus 3k, which is the position vector of the point. And then parallel to a vector, so that means my direction, the required line's direction vector will be similar to this, right? So then I know my B vector also. So then fix it in the formula, that's it. R vector equals to A vector plus lambda times of B. R vector equals A vector plus lambda times of B vector. A is this and B is this. That's it. You get the equation of the line in the vector form. As they have not asked what form they want, we can keep it in vector. If want, learn the Cartesian way also. Chalo, let's take the fifth sum now. Find the equation of a line both in vector and Cartesian form which passes through a point whose position vector is given to us. So in previous one, point is given, here the position vector of the point is given, direction vector is also given, right? So it's both. So let's see whether I have space to do that sum here. 1 minute. Right, so this is going to be my A vector, this is going to be my B vector. So R vector equals to 2i minus j plus 4k plus lambda times of I, lambda times B vector, which is I plus 2j minus k, right? Now this is the vector form. Cartesian form, you change R vector to xi plus yj plus zk. So you get the answer. So I'm writing the Cartesian also here. X minus 2 by 1, y plus 1 by 2 equals z minus 4 by minus 1. Isn't it? R's components is x, y, z. So x minus 2 by 1, z plus 1 by 2, and y plus 1 by 2, and z minus 4 by minus 1. That's the Cartesian equation. 6. Find the equation, Cartesian equation of the line that passes through a point in parallel to another line. So, if a required line is parallel to another line, the direction vector of the lines would be the same. So, take the direction vector from the parallel line. Well, where is that is found? This is the direction vector. So, direction vector of this line is, let's take it as B, which is 3i, 5j and 6k. This would be parallel to the required line, so the direction vector will be the same. Hence, the equation of the line is r vector equals a vector, which is the point vector, 2i plus 4j minus 5k plus lambda times of 3i plus 5j plus 6k. So this is the 6th one. Now, 7th question, they have given the Cartesian equation, want you to form the vector equation. Well, the passing through points are 5, minus 5, this is the passing through point. The 5, minus 4 and 6, and the direction vector are 3, 7 and 2. So, we can directly convert them. R vector equals to the point which is 5, I minus 4j plus 6k plus lambda times of 3i plus 7j plus 2k. Now, if you wanted to know the steps, now I'll tell you. The equation of a line in Cartesian form is x minus x1 by a, y minus y1 by b, z minus z1 by c. X1, Y1, Z1s are the point vector, the point, passing through point. And A, B, C are the direction vectors, the components of the direction vector. So X1 is what? So here it is minus 5, so X1 should be 5 then. And here it is plus 4, so Y1 should be minus 4 then. Z1 is, over here it is 6, so Z should be 6. So this is how we get the direction vector. The passing through point. And then the direction vectors are just the denominator terms. The vector equation and the Cartesian equation. Find the vector and the Cartesian equation of the line that passes through origin and a point. This is an interesting question. So I like to do it in the blackboard. So a line that passing through origin, which is 0, 0, 0, and a passing through point A. Now, an equation of a line to find, we need a point and a position vector. And a direction vector. So point is our choice. We can take origin as the point or A as a point, right? Origin as a point makes our work very easy. Because if origin is the point, so A vector will be 0i plus 0j plus 0k. And direction vector will be OA vector here. The B vector will be OA vector, which will be 5i minus 2j plus 3k. and directly we put it in the formula r vector equals to a vector plus lambda times of b vector. Now, will we be getting the same answer if we choose to take A as the passing through point instead of origin? Absolutely. You will get the same answer, but you need to do a few more steps, etc. Extra. Let's see that. So here I'm going to consider OA vector as my passing through point. OA position vector is my passing. So A vector would be 5i minus 2j plus 3k. And AO vector will be the direction vector because I'm viewing from A, which is going to be my B vector, which will be 0 minus 5, so minus 5i plus 2j and plus 3k, minus 3k. Now R vector equals A vector plus lambda times of B vector. So R vector equals 5i minus 2j plus 3k plus lambda times of minus 5i plus 2j minus 3k. Now, if you find the book answer will be different from this. Once they must have given you the Cartesian equation, they're not given the vector. So, and even if you convert this to Cartesian, you get x minus 5 by minus 5, y plus 2 by 2, z minus 3 by minus 3. But I'm sure you will find this as not the book answer. Why? So take it simpler. Take 5 common out. So this will become x by 5 minus 1 by minus 5. If you take 5 common out, take 5 common out from this, you get 5 times x by 5 minus 1 by minus 5. And then 2 common out from this, so 2 times y by 2 plus 1. 3 common out from this, 3 times z by 3. So this will result in, you can simplify this further, right? So 5 get cancelled, 2 get cancelled, 3 get cancelled. So we get minus x by 5 plus 1, y by 2 plus 1, minus z by 3 plus 1. So plus 1 will get cancelled eventually because everything is equal. So minus x by 5, y by 2 equals minus z by 3. Or we can write it as x by 5, y by minus y by 2 and z by 3. So this is how we get the equation of the line whatever point we choose. So if you take origin as the point, it's very comfortable to get the book answer. But if you take A as the point, you need to do a little bit of work. But both ways you get the same answer, then you have to be sure about that. The angle formula that I've already said. Find the angle between the two lines. So take the direction vector. One will be B1, another one will be B2. Use cos theta equals B1 dot B2 by magnitude of B1 vector, magnitude of B2 vector. So 10 is like that. Just pick B1 and B2 and put it in the formula. 11 is also like that because the denominators are your components of B vectors, right? So B1 vector will be this 2i 5j minus 3k. B2 vector will be this minus 1i a plus 8j plus 4k. Then applied in the formula. 12th one. The lines, find the piece so that the lines are right angles. Right angle means they are perpendicular to each other. Now the given equation is not in the standard form. So before we step into finding the direction vector, convert this into standard form. So it becomes x minus 1 by minus 3, y minus 2 by 2p by 7 and z minus 3 by 2. Now minus 3i plus 2p minus 3i plus 2p by 7j plus 2k will be the direction vector of this line. Likewise for this next one also. So you're taking 7 out and taking it down. So you get x minus 1 by minus 3p by 7, y minus 5 by 1 equals z minus 6 by minus 5. So the denominator's components, you form B2 vector from that. then B1 into B2 equals to 0. B1 dot B2 equals to 0 because if it's perpendicular. And same way for the 13th one also. Okay, so in this video, I've taught you how to find the equation of line, the proof of the formula, the required information, and then how to find the angle between two lines. Hope this is enjoyable for you and hope you're all learned this concept properly. If you like my video, share it with your friends and make it useful to everyone. Thank you.